All right, hello and welcome to the Off by One security stream. I try to do this weekly, but every week sometimes becomes challenging. So I'm going to try and get better about when I don't think I'm going to be available on one particular week to try to record something in advance and then schedule it to release, because I think consistency is kind of cool when you know you can rely on that every single week. I was just chatting with Connor McGar yesterday on Twitter DM anyway about having him come on. So maybe next week, maybe the week after, I have to figure out which slot works the best. We're going to have him on to talk about some kernel exploitation fun and look at some of the mitigations and such in that space. Things have ramped up so exponentially over the years. I guess over the years and exponentially don't match up exactly the same way as it should. But I guess what I mean is the number of mitigations back, 15 to 20 years ago were very minimal. We had data execution prevention. We had ASLR starting to peek its head out here and there. We had some other mitigations like Windows-specific safe SEH or software depth, looking at the structured exception handlers. But my point is not very much. And then when Vista came out on Windows, and I think it was Snow Leopard on Mac, I can't remember exactly, ASLR came out, and it was kind of slow going at first. And then it started to accelerate, and we saw Control Flow Guard, and we used to have the Windows Enhanced Mitigation Experience Toolkit, or EMIT, and that got discontinued, but then they rolled out Exploit Guard on Windows 10 and 11, and that includes over 15 mitigations. And some of these mitigations are ones that you turn on or turn off. Some of them are there by default, and you can't do much about it, especially with regard to the kernel. The kernel mitigations, you don't have a whole lot of control over all of those. And with the different types of code signing and virtualization-based security and all these things getting added in, it's getting tough. I saw a presentation recently from, I can't remember the name, QWERTY, whatever, about the end of use after free bugs within the iPhones and iPads. And that's going to severely hamper the ability to do the jailbreaking and such, and finding bugs that are worth like $2 million when you go to sell them at places like Vupin. So it's getting real hard. I think, I know that's not what we're talking about in this session today, but my mind was on it before jumping on here. And I think that, we used to be able to teach these techniques, and those techniques were ones that you could always count on, and they just worked. And when you teach like an exploit development class, you're like, okay, if you want to go after the structured exception handling chain, SEH, you can overwrite the pointer and point it to a pop ret sequence, and it just always worked. Those techniques, they're not as reliable. They're falling off. So what you're going to see more of are one-off type things where, okay, by doing these things, we were able to get this exploit working. But in order to deal with different mitigations, we had to do all these different things. And, I'm rambling here, but you get my point. I think the day of these tried and true techniques that we can always rely on, such as return-oriented programming, the day is nearing an end. You've got things like shadow stacks and control flow enforcement technology really targeting things like return-oriented programming, which is a technique we like to use. Now, we can still use it today. Those mitigations aren't on by default because most processors don't support them yet. But as technology catches up with the mitigations that are available with the operating systems, those techniques are going to get squashed. They're going to get killed. And then we got to find new ways. So long-winded way of saying, we always used to be able to rely on these cool techniques that under certain conditions always worked reliably, or almost always. And now we're getting a lot more into one-off exploits. So it's still really important to understand all these different techniques that have worked over the years, because you still will see them out there, especially on things like IoT devices or outdated systems in some environments. Like, they're not going away completely, but when you're dealing with a fully patched, modernized system, those techniques aren't there anymore. And you're going to have to rely on your knowledge of how all those things worked historically to try to come up with a way to get something to work in a modern circumstance or situation. The sad thing is all these different bugs out there that the vulnerability is there. You can see it, but you can't exploit it because mitigations are blocking it. I've come across that many times. I mentioned in a prior webcast or stream where use after free in browsers, you can still find use after free bugs, but you can't exploit them. So Microsoft will still patch them if that's the affected vendor, but you can't exploit them because something like memgc or isolated heap or some other protection is preventing you from being able to successfully exploit it. So, it's what's supposed to happen. All this attention that we've brought and put onto security, it's working. But from an exploit perspective, it makes it harder. The good news is, if you're interested in selling exploits, that was one of the options I put for this session, but it didn't win. You're going to make a lot more money when you do get something working because it's so much harder to find them. So you can sell them 10 to 20 times more than what you would have been able to sell it for years ago. Hey, Pablo, good to see you there. Still sad I didn't get to meet you out in, I think it was Berlin. Jamie Geiger was teaching out there. Will this be recorded? Yes, it will be recorded. All these streams are recorded. It takes YouTube a couple hours or so to process it, but it will be available in the Off by One location. So I put a poll out and I put 4 options. Bug bounties was one. Patch diffing was one. I can't remember what the other ones were now, but they didn't win. This one won. So that's what we're going to talk about today. And if you've taken 760 course, the advanced exploit dev course that I teach and co-author at SANS, you've seen a lot of this stuff. But we're going to look at some interesting things that come up here and there and just kind of where we came from and where we are today. I like throwing this slide up here, which I used in an RSA presentation many years ago when I was talking about patch diffing at that particular time. It was like 2016. And we got 2 QR codes here. Don't scan it. I don't even think they're real, but if you're feeling frisky, you can try. But the point is, look on the left, that's the unpatched version. And look on the right, that's the patched version. And tell me where the difference is just by looking at this with your eyes. And kernel exploitation, thanks. And we'll have Connor on soon for that. So you can't see it very easily. You'd have to spend a lot of time and it'd be pretty annoying. And if we go to the next slide, there it is. It's like, oh, you couldn't see that this little block right there on my pointer on the right side, that's the patch. That little square was put in. Now that's kind of the analogy, or not analogy, but example I'm using to compare it to binary diffing, which is, let's say that you're taking a look at JScript 9.dll on a Windows system and a patch was made to it. And you're talking about a library that might have 30, 40, or 50,000 or more functions inside of it. And let's say that 1 or 2 of those functions out of 50,000 had a code change in it. So we're not talking at the function level now. We're getting down to the block level and even further down to the assembly level. It would be extremely time consuming to try and find that without a tool to help you. So what we want is a binary diffing tool that uses different heuristics and different types of pattern matching and string matching and other techniques to determine if there are code changes between 2 versions of the same file. Not all of them are equal. Some of them do a better job. Some of them just do a different job. A couple of the really big ones out there that I personally like is bindiff. We're at bindiff 7 right now, unless 8 came out and I didn't know it. Bindiff, which was originally from Zynamics out of Germany, but they were acquired by Google many years ago, and it's free. And Christian Blickman maintains it, thankfully, and we keep it up to date and are able to use it with the latest versions of IDA Pro. And then we've got another great one, Diaphora, from Doxing Correct. I know I'm mispronouncing his name, but he's a great contributor to the community over the years with different tools, and Diaphora is a fantastic one. Now, bindiff is written in C++ as a plugin to IDA, so it's really fast compared to Diaphora, which is a Python script, which is amazing. It's fast, but it's a higher level language, so it's not going to be as fast as a low level language like C++. Still an amazing tool, actively maintained, and supports other disassemblers besides just IDA Pro. For example, maybe Binary Ninja or Radar 2 or Hopper, I'm not sure, or Ghidra. I can't remember the exact ones that supports it, but I think Radar 2 or Radar, however you pronounce it, is supported. So those are the two big ones. There's other ones like Binary Ninja and Hopper, like I mentioned, for disassemblers, and then other patch diffing tools like Turbo Diff is an old one that was written by Core Security. That one's still good because it works with the old free versions of IDA. So depending on the version of IDA Pro, if that's your disassembler of choice, plugins may or may not be disabled or enabled if you don't have a licensed version, if you're using a demo version or a free version. So Turbo Diff was a nice fail-safe one that we could use. There's also Patch Diff 2. And there's Darn Grim was another one. So lots of great ones that have come out over the years. But we're going to use BinDiff in this session because it is probably the fastest one out there and has the most features, I would say. But Diaphora is, again, fantastic. So there's lots to talk about here. I don't like these sessions to be a slideshow. So unless I need slides, I don't want to use those. I just want to get straight to hands on the keyboard so we can kind of walk through something. Now, I've gone to the Microsoft Update Catalog site here, and it used to be that there was on MSDN or TechNet, somewhere on Microsoft's site, each Patch Tuesday. So Microsoft back 20 years ago, Bill Gates released a trustworthy computing memo. It's an infamous email that came out from Bill Gates, and it basically said, we need to do better as a company from a security perspective because people are finding lots of vulnerabilities and exploiting them, and it's making us look bad. So 20 years ago is back when Microsoft started Patch Tuesday and also SDL, which is Security Development Lifecycle. And they came out with threat models like Stride and Dread for risk assessments. And the Security Development Lifecycle was all about mapping security processes into each phase of the development lifecycle. So you've got requirements and design and implementation and validation and release. You would have training on the front of them, and then you would map in security to each phase. We're not going to go into all the details there, but that's some of the stuff that started 20 years ago when Microsoft started to get really serious about security. So you used to be able to go onto the MSDN or TechNet website, whatever, and each Patch Tuesday, you would see a list of all the patches. And it was really simple because you could click on an update like MS17 for 2017-123. And there was a knowledge base article associated with it. The CVEs were listed there. And there'd be a nice summary or description of that vulnerability and what the patch is addressing. And the more details you got handed to you on that page, the easier it could be for you to find the vulnerability and determine whether or not it's something you want to even look at. Because to be fair, just like with an exploit development in general, finding bugs is the easy part. Writing a fuzzer and crashing a process is the easy part. The hard part is looking at the context of the crash condition, determining whether or not it looks like something you can weaponize, and then actually going through and doing that. That's the hard part, because oftentimes myself, and I'm sure plenty of you, have spent countless hours trying to weaponize something or even just debug something, and you're not able to get very far. I've got countless examples, and they all stick in my brain because they kind of scar you a bit, but you also learn a lot from that. So cool. Yeah, welcome. Just if I look into the right here, I'm just checking the messages here. So great. Yeah, there's different formats that have come out over the years for different things. That's one of the beautiful things about Microsoft is it's consistently inconsistent with the way in which things are published or released, or the way symbols are passed out, or the way that the patch management process works, or where you can find details about patch vulnerabilities. It's not as, I mean, it's funny. Someone from Microsoft might argue, well, it's actually a lot more organized and neat now. From my perspective, it's a lot harder to get to the information I want when it comes to looking at a specific vulnerability. Some people will take a snapshot of a fully patched Windows system, and then they'll apply this month's Patch Tuesday patches to the system. And then they'll go and look at any modified files in System32 that have been modified like in the last 30 days. Because you know that that's the files that have had changes made to them once the patch management process did its thing. You can also look in WinSXS and such. So, and then you could revert back and then grab the old version. Like, that's not the most efficient way to do it. There are some websites out there that try to maintain all the different versions of Microsoft files, like DLLs and driver files and such. And those can be super useful for sure as well. I like to do it myself so I know exactly what I'm looking at. Plus, you run into a thing where there's oftentimes manifest data that comes with different applications and processes. And it used to be this thing called DLL hell, which has to do with DLL versioning. And WinSXS tries to make that more organized, and it does a good job, but it's still complicated. But the reason multiple versions of DLLs, the same DLL, like NTDLL, for example, there might be a bunch of versions stored somewhere in WinSXS because it has to do with versioning and dependencies. Like I said, there might be manifest data that it says, I need this certain version of NTDLL for this specific application to work, as where all the other ones are going to use the latest version. So you get into lots of great things like that. So what we're going to do here is I want to do a couple things. I've already downloaded a pretty large patch file that was over 0.5 GB. I tried to prep some things in advance so we're not sitting here waiting for things to happen. I did, if you've heard of Martha Stewart, I did a little bit of that version as well, where I pre-baked some things, but I'm also going to show you how we get started, and then I'll just jump back over to the already baked version so we don't have to sit here and wait for things to expand. But I want to look at a couple things. I want to look at how you get the patches today and download them. An important thing is making sure you are grabbing the right versions of things. It used to be, I keep saying used to be because I miss those old days, where when you would go and look at a specific vulnerability or a specific patch, it was laid out by operating system, and it would say Windows Vista, Service Pack 1, Windows 7, Service Pack 0, Windows 8, whatever. And you could click on the patch and download the patch file. And then right next to it on the right, it would say updates replaced. And that's where you go and get the other version of the file that you want to diff against. It made it super easy because it can get complicated when you think you're diffing one version of something against another version of something, and you think it's the same build or the same version of that operating system, like Pro or Enterprise or Home, or 32 and 64-bit, and just many other factors. So you need to make sure you're diffing the right version of something against the most recent version, the last time that file was updated. So right here, we're in the Microsoft Update Catalog, which is the latest and greatest way to do things. And we want to put in the year first. There's no specific order that you have to do, but I'll say, let's go to 2022-10. That would be October 2022, so this month. And then we can put in the architecture. So I'll say x64. And then I'm going to put in quotes Windows 10, because otherwise Windows 11 and other stuff's going to pop up. And then finally, the build of Windows 10. So I'll say 22H2. And we hit enter. And we get this nice list that's very short. If we don't do it this way, and I just say cumulative Windows 10, watch how many hits we're going to get. We get the first 1,000 are returned. So that's obviously not very useful. So using that kind of format allows you to get right to what you want to look at. But even in this case, we still got a bunch of versions listed. So you can see on the right under classification, it says updates, critical updates, security updates. And then over on the left, you see other things like dynamic update, cumulative update. So there's different versions of things. So a critical update is typically going to be something that's patched as like an emergency out of band patch. So that's where you're going to get likely just the files associated with the specific vulnerability that was caught in the wild. Maybe a 0-day got discovered. The dynamic updates, those include things like some Windows update components, as well as Windows recovery environment updates and data. You're going to see things like SSU for servicing stack updates, which has to do with updating the update process itself. And preview sometimes is listed there. Do we see any preview here? No, nope. The previews haven't come out for October yet. But if we were to go and switch this to September, so let's try that 2022-09 x64 Windows 10, and then let's do 22. I don't think there was a 22H1. Let's do 21H1. We should see in here a preview. So see how these top ones say preview? And those dates are clearly not Patch Tuesday. Those came out after the fact at some point. Those previews are typically not security updates. So those are like previews for other features and such, but not security stuff. If security updates are coming back, those are the critical updates that have to do with typically like a 0-day caught in the wild. So what I would do is find the right version, and I put x64 because otherwise x86 will show up as well. And we find the right one. So the one I'd want, I typically go and look for the large ones because they've been, Windows 10 has always been cumulative. And what that means is there's a bunch of different builds that have come out with Windows 10. Originally, Microsoft said, we're not going to have any more versions of Windows after Windows 10. And then they changed their mind, and now we've got Windows 11. Which clearly is going to fail as an operating system because every other versions of Windows fails. So Windows 12 or whatever it is will be the next successful one if history repeats itself. So we've got all these builds. We've got the 20H1, 20H2, 21H1, and those are the like big updates. And then we've got the build numbers. So like 1803, 1909, and there's a bunch of them. Sometimes they get they go out of service and they no longer support them. Some of them, for whatever reason, end up being like a long-term service update that sticks around for a while. So for years, but then you've got to go and look at the end of life for those. And to me, it makes it more complicated because if you're a Windows administrator and you're using one of these dozen or so builds, you've got to keep track as to when that specific build is going to be retired so that you can move to another one and kind of standardize or stabilize on that specific build. So patch management becomes a bit complex versus how it used to be. And so we see in here that there is a cumulative update for Windows 10 version 21H1, 64-bit. It says security updates, and then it's 675 megs. It's so large because in the old days, each Patch Tuesday, you would download the specific patch file. So when you extract a patch, it was just the replacement DLL or driver or whatever it was for that specific vulnerability. But now it's cumulative. So you end up with these enormous files because it's got every single version of all the files that have been modified since that build came out. So some of these Windows 10 builds are several years old, so they can get over a gig. Some of them are like 1.4 gigabytes, massive, because it's got every file in there. So when you go and download and extract these things or expand it, it's thousands or tens of thousands of folders and files and manifest data and other junk in there. We want to get to the important stuff. So we would find whichever version. Let's say that we wanted to diff. Now remember, not every file gets changed every month. Some of them get changed more often. If it's associated with a browser, it's going to get updated every month because there's oftentimes browser vulns discovered. But let's say it's NTDLL. NTDLL could have been patched in September, and then it could have been patched again in October, but maybe not. Maybe the last time it was patched before October was in March of 2022. You need to find the right versions because those are the ones you want to diff against. It also used to be the case that the patch files, let's say it's a DLL, when you extract or expand it, it was the full file. So if you saw ntdll.dll, it would be the entire library. But now for some years now, we've got what's called Delta files. So these Delta files are differentials that allow you to take a current version, apply a reverse delta to get to the base build of that specific file, and then you apply a forward delta to get you wherever you want to go. So once you get it, once you get the correct reverse delta applied to the DLL or whatever file you want to mess with, you're back to the OEM build original part. Then you can apply any forward delta from any month where there is a patch to that file, and you'll get to the current version for that specific month. So Jamie Geiger, who's a co-author of mine, he's actually teaching 760 right now today. He wrote a tool called Delta Patch, which handles that for us. It allows us to apply the reverse and forward deltas using the appropriate MS Delta library files. It's quite a simple process. There's a CRC in the front, and then it's just a delta that gets applied, bring it back to OEM, apply the forward delta, and you're where you want to be. So we download this file here, and I've already downloaded that one. This is actually this is the Windows 10 version for, I forget which build, but it's for September 2022. So it's last month's file. And you can see it's 691 megabytes, so it's quite large. And I've also got some older files here, 2020-10 for October and 2020-11 for November. That's a couple years ago. Because the nice thing, you can go to any historical point on the catalog website and you can download the specific cumulative updates. There's been a ton of cases where, I'll give you one example. It's a quite old example, but it's one that popped into my head first. There was a old bug discovered and by EI Digital Security, and then Alexander Sotorov, who's a well-known researcher, he was looking at that bug and he grabbed some old diffs or some old update files and was looking around, and he found the same vulnerability one cross-reference away, the exact same vulnerability, one cross-reference away. So I'm saying that because there's a couple really great things about binary diffing and patch diffing. And for whatever reason, there's not a whole lot of people doing this. And I've been doing this for 15 years or so. And here we are 15 years later, and there's still not a whole lot of people doing it. I've had a day of binary diffing in this course or whatever version of this course since 2008, when this course used to be called 709. And the only other class I've seen out there is one by the Diaphora's author, Joxin Corrette, who does a couple-day class at different conferences on using Diaphora to do binary diffing. I'm sure there's a couple more out there, but I'm surprised that there's not that many, because there's two main points for binary diffing. One is to weaponize patched vulnerabilities as soon as you can. That's called an end-day or one-day exploit. The idea is that, as we know, most organizations do not patch immediately. And if they do, they probably don't patch everything. Most organizations lag behind, and it may take weeks or months or longer for them to patch something. So if Patch Tuesday comes out and you've got the skills to reverse engineer and diff and find a vulnerability that was corrected, and you can weaponize that into an exploit, the chances are you'll be able to use that against a lot of targets. It's extremely valuable. It's so valuable that I used to work, I won't mention the company, but I used to do contract work for one specific company who had a shopping list of valuable CVEs, because most vulnerabilities are not publicly disclosed. Over 90% are privately disclosed. So that means that most of the bugs or vulnerabilities discovered out there, there is no corresponding exploit. So if you've got the skill set to weaponize those patched vulnerabilities, they're worth money. There are buyers out there. The example I was just giving you is I used to get a shopping list of this particular company's most desired CVEs that are patched but with no corresponding exploit. This was a company who wanted to be able to tell their customers that they have more weaponized, privately disclosed CVEs than anyone else out there, because that's extremely valuable. If you can say that and it's true, your product is going to be worth more money to me than another one, so I'll buy yours. So he would have a shopping list he would give to me each month or so, and it had like 30 or 40 CVEs, and it had a price tag next to it. One of them in particular I weaponized was a Wireshark vulnerability. This is years ago. And the reason that they wanted this Wireshark vulnerability weaponized is because to run Wireshark and sniff, you've got to run as root. So it's instantly a root exploit. And it was a format string bug. There was a packet parsing a header vulnerability. It was a format string bug where you could get remote code execution on Linux boxes. And they paid me $5,000 for it. Like, it took me maybe 6 hours to figure it out and another few hours to weaponize it. That one actually ended up being pretty easy. But I was on a plane for most of it, and that's pretty cool. Like, if you got the skill set to do that, this is one of the reasons why we want to look at binary diffing, to weaponize vulnerabilities that have been patched, but there's no corresponding public exploit. I don't remember the CVE for that one. I'd have to go look it up, but it was a specific packet type that was a header parsing vulnerability that was missing a format string. I don't remember. This is a while ago. It's like 10 years ago, though. It's just the one that popped in my head. So that's one reason why it's important. The other big selling point as to why you should be interested in this is it helps you find new vulnerabilities, new 0 days. So you can use patched vulnerabilities, the knowledge you gain, to find 0 days. The example I just gave you, where Alexander Sotorov discovered it, he saw that the way that Microsoft fixed something was by putting a bounds check in. So he went and searched for some of the same assembly. You could write it up in IDA Python. Search for some of the same assembly in the same DLL or other DLLs, and he found it one cross-reference away. It happens all the time. So that's the other selling point for you on this, why you should care. Because by understanding how Microsoft patches specific vulnerability types, you can potentially find new ones. And that's the two reasons. So we've downloaded this, and you can see it's a quite large file at the bottom. Now, what I'm going to do is two things. I'm going to show you how you would go about expanding a patch cumulative update, and then we'll look at using a tool called patch extract to optimize and dynamically do it for you and make it faster. And then we're going to look at grabbing a file from WinSXS so that we can apply the reverse delta to get it back to the OEM build. And then we'll apply a forward delta for 2 separate months so that we can then diff the two files together and see if it works. You'll know if you did it wrong because you'll have tons of false positives. It'll show you that there are thousands of functions with code changes in it, and that's just not true. Microsoft doesn't obfuscate the patch management process. I believe they want to, but I believe they don't because it hinders developers' ability to easily work with and debug Windows applications. So thankfully, it makes our job easier because we can get the debugging symbols from Microsoft is very generous with that. And we can also we don't have to worry about patch obfuscation. So I'm going to jump over to PowerShell here. And I'm in my demo folder. You can see the patch file down here. That's the one for September 2022. And we're going to use the expand tool. So first thing I'm going to do is just create a new folder. So make directory. We'll do 2022-9. And then I'm going to move that patch file into 2022-9. So now it's in there. And let's go to that folder. So you can see I'm just in that folder I just created with the patch file. And we're going to use expand. So before I do that, I'm going to create a couple of folders. So I'll say make directory extract and make directory patch. Now this will show you something interesting that Microsoft does sometimes, which breaks some of these extraction techniques. So we're going to say expand minus capital F : asterisk, and then the patch file. And we're going to expand it to the ext folder, extract. So it's extracting it, and you can see what it's extracted. You see a cab file in there, a couple cab files maybe. Let's go and take a look. So ls ext, extract. There's a few files. We got an XML file, a couple cabinet files, a text file. So there's like some manifest data and such in there. There's data that's specific for like WSUSE or Windows Update for Business, those different patch management tools. But more importantly, there's this really large cab file here. That's where the patches are. SSU is going to be the servicing stack updates, which are changes to the update process itself potentially. So I just want to extract or expand that cabinet file, the large one. So we're going to say expand minus capital F again, colon asterisk. We're going to go into the extract folder, and then the one we want is that large cabinet file. And just to verify it's the right one. Yeah, so it's already populated there for us. Now, normally in the past, when we would do the expansion of this cabinet file, that would be the one that expands all the different folders that have all the patches. Now, this is going all the way back from the original build. So it's going to be tens of thousands, and it takes a long time, tens of thousands of folders and files. Watch what happens. So I'm going to tell it to extract to the to the patch folder. Now we let it go, and it's like, well, the stuff that it expanded looks very similar to the stuff that it already expanded. I mean, it's a little bit different. There's some differences, but some of it looks the same. So kind of like, ooh, okay, so ls patch, and we've got these few files. Normally, this would have been what kicks off the crazy expansion of all the thousands of files. But instead, we get another cabinet file that's quite large and a servicing stack update again. So I'm like, okay, let's do that again. So expand minus F asterisk, and then we're going to go to patch and the cabinet file. So I'm like, okay, this one must be the one that's going to kick off the crazy expansion. Let's let it run to the patch file. And it's like, nope, we're just going to, now we've got two cabinet files. So it's split the cabinet files, but it looks like we get a lot of the same stuff again. So ls patch. And yeah, it's like there's a couple new files in there. Like it split the cabinet files. So yet another layer of nested cabinet files. Now I'm going to go in and expand again. Now this is the one that should kick it off finally. But my point is, like, you'll use, if you ever go to use patch extract 1 month and it fails, it should go recursively and just handle all that. But if it breaks, this could be one of the reasons for it. So I'm going to go ahead and expand again. And that should be the big one, right? 501-7308. This is number. Oh, let's do that again. Hold on here. Oh, cab 1. Sorry, cab 1. That's the one I want. So we now run this. Now I would normally pipe it to out null so we don't see all the output, but I just want you to see what it's doing. And I'm going to stop it anyway. So now it's, what did I do wrong here? Expand. Oh, I spelled exe wrong. There we go. So watch what it does now. So now it's going through and you're seeing a ton of stuff fly by on the screen. This will take 20 minutes possibly. So I'm not gonna do that. I'm gonna go ahead and kill that. But if we do an ls and patch, nothing's there yet because it was just adding it to the queue, the extraction queue, and it didn't start doing it yet. I'm actually going to run this against the cab2 file and let it run in the background unless it causes me issues, because this is a much smaller file. So you can see the names of things flying by. I know it's kind of hard to read them, but like there's some names that are clearly patch files. We see names of things that are like, I just saw Hyper-V fly by and touchpad things, whatever else. So once it's done, adding it to the extraction queue, it'll actually expand the stuff and we'll be left with a ton of folders that we can go into. So I'm going to let that run in the background here. If I go into an old folder that I've done in the past and expanded, you can see in here the results of what patch extracted. So Greg Linares, who goes by Laughing Mantis on Twitter, wrote the tool patch extract years ago, and we've updated it since then. Jamie Geiger has a version. Randall can post a link up to patch extract here in a moment. Randall's our lovely marketing guy working in the background of the stream. He'll post a link up for patch extract, but that was a tool written by Greg Linares that organizes things, because when we look at the result of the extraction I'm doing in the background, you'll see it's a mess. So when we run patch extract and let it do its thing, it creates all these folders and it sorts things, because you'll see stuff for C#.NET code. It puts that into the MSIL folder. It has stuff for WoW 64, so the 32-bit emulation. It puts that into that folder. There's a ton of junk data and manifest data. It puts that in there. Then what we really care about is going to be in this x64 folder. Now, if I scroll down, you can see there's tons and tons of folders in there. Now, this example I'm showing you is quite old extraction that I did. So there's not nearly as many as the one that I'm extracting right now in the background, but that's fine. All these folders, we can click on any of them, like this core shell one. And when we go inside, you can see there's an F and an R. F is forward, R is reverse, and then it could also be N for null differential, which means the new file being added. So if we go into the reverse folder here, it's core shell.dll. Look at the size of it, 69 kilobytes. That's certainly not a DLL, a full DLL. This is the differential. And if you open this up, there's a CRC32 at the front, and then the diff data. When you use delta patch that we'll be using soon to apply the reverse differential against the real DLL, it should take us back to the OEM build. And then what you can do is apply a forward delta for an appropriate month, and you can get that DLL up to whatever version that you want to get it up to. So I'm going to demo this while that extraction is going on in the background. First thing we're going to need to do, though, if I go back here to my demo folder, I'm going to want to grab a version of NTDLL from my WinSXS folder and also grab its reverse differential associated with that version of NTDLL so I can get it back to the appropriate original build file. Then I'm going to apply the forward differentials for October and for November so that we can have two files to then diff against. And if I did it successfully, when we look at it in IDA Pro and we run bin diff, we should only see a few changed functions, and that's how we know we did it right. So let's bring up another PowerShell ISE. And what I'm going to do now is grab the NTDLL version. So I need to search for it. So let me think. I'm assuming NTDLL has changed between those 2 months. It might be a bad assumption. We'll find out. So I'm going to say GCI for get child item, and then minus recurse. And then we're going to go to C:\/ Windows Win XSS. Now from inside here, we're going to apply a filter, and I'm going to look for ntdll.dll. And this should work pretty quickly. You could pipe it and do it that way and do name equals and all, but that's going to be about a lot slower. This is going slower than I normally would like it to anyway, because that other PowerShell stuff's going on in the background with that expansion. So right here, I control C because all I need is one hit. And you could see it point me to this really crazy folder here. And you see that there's the actual NTDLL file. So here's the actual length of NTDLL. That's the actual size. This is the real file. Then you can see that there's an F folder and then an R folder in that same directory. That's the forward and reverse differential. So I want the reverse delta file and I want the real DLL file. So I'm going to do this in Explorer so it's easier for me. And I'm going to go to this location in Explorer. So first I'm going to create a folder here called NTDLL. And I'm going to go to that location and WinSXS. So here is that real version of NTDLL, and I need that in the reverse diff. So I'm going to grab those two and just paste them into my NTDLL folder. And there they are. Now I'm going to use Delta Patch with PowerShell here. So let me go into my desktop demo folder. All right, so this command is quite long. Hopefully I don't mess it up, but I'm going to say delta patch.py, and then we're going to say minus input. Now this is going to be the real version of NTDLL that I grabbed from WinSXS. So I'll say NTDLL, NTDLL.dll. So that's the real file. And now I'm going to tell it what output file I want to create. So I'm doing 2020 October and 2020 November. So I'm going to create a file called ntdll.2020-10.dll. That's going to be the output. So now I need to go and point it to the, I need to do the reverse differential and the forward differential. So let's go to ntdll/reverse ntdll. So that should allow us to apply the reverse differential. And then now I'm going to say 2020-10 x64 ntdll. There it is. Forward delta NTDLL. So that's a long command, right? To look at that again, we're running delta patch.py script. The input file is the NTDLL version that we grabbed from WinSXS. That's the full version. Minus O. The output file is going to be 2020-10 because it's the October one that I'm doing. Then I'm saying apply the reverse differential from WinSXS against that file that we grabbed from WinSXS. Then now it'll be at the base build. We're saying apply the forward delta from the October 2020 date forward delta. We hit enter. And it says applied 2 patches successfully. So it worked. Great. Now let's do the other one. So /delta patch.py minus I for input, ntdll, ntdll.dll. We're going to call the output file this time 2020-11.dll. Then we got to apply the reverse delta again, and then the forward delta. So /2020-11 x64 ntdll. Wait for it to auto. It's going slow. I hit tab a couple times. It's just taking a moment because the other PowerShell stuff's going on in the background with expanding. There it is. And then forward delta NTDLL. And we applied that one. So it looks like it worked successfully. If we go back to my demo folder, we now have NTDLL 2020-10 and NTDLL 2020-11. And if this works, we should be able to open up an IDA and we'll know if it worked. So let me go and bring up IDA. I'm gonna have to kill that that script running because IDA's gonna be incredibly slow if I let it continue. So I'm gonna hit Control C and just stop that. Let's bring up IDA. I chose NTDLL because it's not that big of an that big of a DLL, but it's still something meaningful. Yeah, it's still taking a long time. I'm hoping that bindiff doesn't crash because if you've ever used bindiff before, it likes eating up a ton of RAM when it first starts building out and graphing out things. So it could crash. We'll see what happens here. I gave this thing 8 gigs to try and prevent that, but we'll see. So we'll go to new. I'm going to go to my desktop demo folder, grab the November version first. It's going to go and grab the symbol files here in a moment. All right, so it's downloading the symbols pretty fast. So I think it's speeding up now that we killed. If you ever want to speed up IDA, close all the windows and then reset your desktop afterward because this little bar at the top, the navigator bar and the function names windows, those two alone are really slowing things down. So just hide the navigator toolbar and close the function names window, and it goes way faster. You can close more of them, but those are the two ones that are the biggest headache. And you should notice at the very bottom, it's speeding up. I know it's kind of hard to see on my screen. So while we're waiting for this to happen, I'm going to go back over to Explorer here and go into 2022-9 and go into patch. So you could see how it was expanding things now. It wasn't anywhere near done, but look at how many files are there. That's all the manifest data at the bottom, or a lot of it anyway. There's a ton of AMD 64 folders. There's a ton of x86 folders. That's amazing that even in a small stream like what I'm doing, this spam shows up on the comments. All those bots out there. But you could go into these and see how every one of them has a forward and reverse delta. So just like I showed you a moment ago, that's how that would work. So analysis is finished. I'm going to go ahead and close this one. And we're going to open the October one. I always like to, it's just a personal preference. When you're doing diffing, when you're doing diffing, you can only have one file open at a time inside IDA unless you have multiple versions of IDA running. And I like to have the unpatched version loaded as the input file so that when I do a diff and we see references to primary and secondary, you'll see what I mean in a moment if you haven't seen this before. Primary is what's loaded in, and I know it's always the unpatched version because that's the way I just do it by default. And then secondary, we're always dipping against the patched version. So on the left side of the screen is the unpatched version. On the right side of the screen is the patched version. It's not important, but a good habit to get into. All right, so I should be finishing up here in a moment, and I'll reset my desktop. All right, it is done. So let me go and put the navigator bar back on, not that we need it. And then I'm going to reset the desktop. So I got my functions window back. Cool. So now I'm going to save this and we're going to do a diff. So hopefully the diff is successful. I'm going to run that against the November version. Now, again, we'll know if this worked or not because when it shows us the matched functions tab, there should be very few functions that have changes in them. That's not always true. So if you're diffing like a MS Edge HTML against another version of MS Edge HTML or JScript 9 or whatever, you're going to see a lot of changes because there's so many updates made to that every month. But something like a regular DLL, it should be very few functions that have had changes, or else you probably messed something up by accident. All right, so it's performed the diff, it's done. So we see nothing in the secondary and primary unmatched. The primary unmatched would have things that are in the unpatched version that are not in the patched version. Secondary unmatched would be functions that are in the patched version that are not in the unpatched version. That's what those tabs are. So let me kill those and get us to the matched functions. Now, when I click on similarity, there are how many functions in this? Almost 4,000 functions in NTDLL in this version. And when we click on similarity, see how we only have 7 or so functions that have changes, and the rest of them are all a perfect match of 1. So this shows you that it worked because as you can imagine, if you diffed any wrong version against another version, probably every function is going to have changes in it, and it's going to be awful. So now we can see specifically that RTLP, free heap, reallocate, allocate. So they made changes to the heap allocation functions here. And then there's also allocate string routine, allocate heap internal. So for whatever reason, it doesn't mean it has to be a security fix. Like in this case, unless they're patching some kind of heap metadata vulnerability, it's most likely a performance change. They probably found a way to change something to make it increase the performance. So it's not always going to be security fixes. That's something to keep in mind. But let's try to do a visual diff real quick. I'll just do it against this string routine function. and I right click and go down to view flow graphs. Now this is where it might crash because bindiff tries to eat up all the memory with Java. So if it crashes, I won't be able to show this part probably. If you look at Task Manager or your performance monitor, it will show you that your RAM is just going up gig, 2 gigs, 3 gigs, 4 gigs. We made it. Phew. So now this looks like it's a really small function. That's because it's using what's called proximity browser inside of IDA, and it's only showing you a very small subset because the function is likely very large. If you want to see the whole function, you can go up here to your view option or mode option, I mean, and get rid of proximity browsing, and then watch what happens. It's going to relay things out, and we're going to see the entire function at once. This might cause it to crash too. So it's ugly for a moment. It's going to organize things. If you notice up in the top right and top left, all that clustered stuff, because it's trying to make sense of everything and graph it out successfully. That's why it only shows you snippets, because it's a mess. There it goes. So that's the whole function. So yeah, not a small function, quite large in fact. Now what you typically want to do is if you start to zoom in here, you can see there's different colors. There's like this yellowish brownish color. There's this greenish like teal color, and then there's this pink reddish color. The reddish color one means that that block doesn't exist in the other side. Green blocks mean that the block exists on both sides and they're identical. The yellowish block means that the block exists on both sides, but there's assembly level differences between the two. So if you were approaching this and trying to find a vulnerability, you would, of course, want to look at the red blocks first, because that's new code that got added in, not just changed. So we can right-click on these blocks and say zoom, and it will take us in. And you can see there's no existence of this block on the patched version. On the unpatched version, it's there. It's not on the patched version. So we would, of course, want to look up a little bit and say, well, what's leading us to this? Now, again, I don't think that this is a vulnerability that's being patched, because since the changes were only made to allocation routines, it's probably just some kind of performance increase. It could be a bug. What we'd want to do is look at the vulnerability announcements for the month for Patch Tuesday. And we want to see, is there some kind of announcement that says a vulnerability was discovered in the way in which memory management is performed? Because if that was listed, then we might be able to correspond and assume that there was a vulnerability that was patched. But oftentimes we're looking for something like Windows RPC service on certain versions of Windows is vulnerable to a heap overflow. And that's all they're going to tell you. But that tells you to go in and look specifically for changes to the RPC associated libraries or drivers. And then you would say, okay, I got to go write a custom RPC client so I can start messing with that and setting up the debugging. And this is where the work begins. The easy part is what I just showed you. The work then is trying to figure out what got fixed, and then figuring out how to get to those lines of code in an unpatched version of Windows for that particular process, and then start to obviously evaluate the context and determine whether or not you can see what the vulnerability is. Sometimes it's really easy and it's just like a bounce check or something. Sometimes it's not. Now, there was one other script I'll tell you about before I close out here, because we're already at an hour. If we go to the demo folder, you might have noticed another PowerShell script called patch clean. Down here at the bottom, patch clean. I'm just going to open it up with Notepad++ real quick. What it's doing, if we go down here, so I'm looking for something specific. 60 in here now? Yeah, there it is. All right, so see this add days minus 60 right there? I know it's really small. What patch clean is doing is, if we go back over and look at one of these folders and you see how many folders there are in here. Well, those are manifest folder or files, but you can see these folders in here. There's going to be tens of thousands of them. And now notice when I go in here. So this is September 2022's cumulative update. We're looking at the reverse differential file. Notice that it says it was updated, it was modified in July 2022. That means that this file was not patched for September 2022 because the modified date would have been sometime after the patch Tuesday for August up to September. So now you probably see where I'm going with this patch clean thing. With patch clean, we can parse through all the folders and it looks at the modified time to see if the modified date is within a window that you set. You can say in the last 30 days. So let's say it's patch Tuesday today. I would set that value to 30 and I would say only tell me the files that have had changes to them in the last 30 days. Because remember, it's got the historical data in there since the build came out months, years ago. So it then organizes things and it creates a folder for you that includes all the folders whose contents have been modified in the last 30 days. That makes your life so much easier because then you might only have like 30 folders instead of 30,000 folders. And you know that those 30 folders have the files in them that are associated with this month's patch Tuesday. So you go and correspond it to the vulnerability announcements, and then you're like, oh, it says there's an RPC vulnerability that's addressed, and I see an RPC DLL modification or driver modification. That's how you know which ones you want to diff. That's an important note, and I'm glad I remembered to say that because I almost forgot. That is the gist. That is what I wanted to share with you in this webcast or stream or whatever we call it. So I hope that it was valuable to you. Like I said, if you have ideas for upcoming streams that you want to see, tweet them at me or post them in the comments after this YouTube video gets processed. All this material comes from the SANS Sec 760 course. We spend a whole day on looking at, or beyond the day, but primarily a whole day looking at how to actually find the vulnerabilities and deal with them and do things with them. But thanks. Hopefully next up we'll have Connor McGar or someone else on the stream. I hope I will do this next Friday. We'll see how the week goes. If not, I'll try to record something in advance. Last thing I'll say is we've got Pen Test Hackfest for SANS coming up in November in Washington, D.C. And we've got a ton of, it's only $325 in person and it's free online. And the reason I'm pitching this one is because we've got like an IoT hacking village, a hardware hacking session, lockpicking. We've got a curriculum CTF where you can win a SANS course as a prize. We're also working on trying to get the Crystal Method there as doing a DJ session. So like, it's going to be a really awesome event. And it's in November, like November 14th, 15th, right around that time. If you can make it, that'd be awesome. Check it out. Randall just posted up the link. Again, I normally don't pitch stuff like that, but I can't wait to go. It's going to be a neat event. But otherwise, have a great weekend, and we will see you next time. Thank you.